Now listen to me. So I will continue. In fact, this is the starting of semiconductors. Last class, what we did was some independent topics. So today's class will actually start with the chapter semiconductors. Now listen. Solids, here, solids can be classified into three based on how they conduct. First one is called conductor, second one is called semiconductor, and third one is called insulator. This you should know from your high school also. There are three types of solids based on conductivity. First one is conductor, semiconductor, insulator. Now you know conductor will conduct electricity, insulator will not conduct electricity, and semiconductor will partially conduct electricity. This much you should know from school. Conductor will conduct 100% electricity. Insulator will not conduct any electricity. Anything between 0 and 100 is semiconductor. Anything between 0 and 100 is semiconductor. Best example for conductor is all metals. Best example for insulator is wood, plastic, rubber, etc. And the best example of semiconductor is silicon and germanium. No need to write, I'm just giving you basic idea. Okay. So let us do it again. So if I ask you how many types of solids are there, in this chapter, remember we are dealing only with solids, we're not dealing with liquids and gases. And based on electrical conductivity, means how they conduct, solids are classified as conductors, semiconductors, and insulators. Now, you should know conductor, as the name suggests, complete electricity is conducted. Insulator, nothing is conducted. And in semiconductor, partially is conducted. Okay. Best example of conductor is metal, all metals. Best example of semiconductor is silicon and germanium, and best example of insulator is wood, glass, plastic, rubber, etc. Okay, this is your high school definition. But in 11th standard also, I have to define what is a conductor, I have to define what is a semiconductor, I have to define what is an insulator. Therefore, listen to me very well. What or who is responsible for conduction of electricity in a solid? Who is responsible for conduction of electricity in a solid? Answer is free electrons, not electrons. If I ask you who is responsible for conduction of electricity, you will tell me electrons are responsible for conduction. It is partially correct. Not any electron, only free electrons are responsible for conduction of electricity in a solid, free electrons. Now, when is an electron free? Or what is the difference between free electrons and not free electrons? When is an electron free? An electron is free if it is not a part of any atom. Okay, an electron is free if it is not a part of any atom. Now from chemistry, you know that this is nucleus, first orbital, second orbital, third orbital. Last orbital is called valence band or valence orbital. Correct? From chemistry, you know that the outermost shell of an atom is called valence shell, or outermost orbital of an atom is called valence orbital. Now, if electron is in the valence orbital, is it free or it is not free? My question to you. If electron is in the valence orbital, is it free or is it not free? Answer is, it is not free because it is still a part of an atom. It is still a part of an atom. Correct? Now, can I say if electron can jump out of valence band, then it is free because valence band is the outermost band. Therefore, if electron can jump out of valence band, then the electron is free. Then the electron is out of the atom. And what is a free electron? An electron which does not belong to any atom is called as free electron. Therefore, if the electron jumps out of the valence band, then it is free. So any space outside the valence band is called as conduction band. Any space outside the valence band is called as conduction band. Therefore, when is electron free? If I ask you, Simple answer is if electron can jump from valence band to conduction band. What is conduction band? A band in which electrons are free to conduct. That is called conduction band. It is no band. It is outer space where electrons are free. So let me repeat from the beginning. If I classify solids, there are three types: conductor, semiconductor, and insulator. Conductor will conduct electricity, semiconductor will partially conduct electricity, and insulator will not conduct electricity. Conductor examples are metals, semiconductors examples silicon and germanium, and insulators example is wood, glass, plastic. Okay. Conductors will conduct electricity, insulators will not conduct electricity, and semiconductor will partially conduct electricity. Now, who is responsible for conduction of electricity? Who is responsible? Free electrons are responsible, not electrons. If you tell me electrons are responsible for conducting electricity, it is partially correct. It is not completely correct. Therefore, I can say free electrons are responsible for conducting electricity. Now, when is an electron free? Question is, when is an electron free? Answer is, when electron is not a part of any atom, it is free. When electron is not a part of any atom, it is free. Therefore, if electron can jump out of valence band, it is free. Now, if electron is in the valence band, is the electron free? Answer is no, because valence band is also a part of an atom. Therefore, electron, when it is as a part of a valence band, it is still a part of an atom. Therefore, only if the electron can jump out of valence band into something called conduction band, it is free. Therefore, I will ask you, when is an electron free, or how do I make an electron free? You will tell me, I can make an electron free if the electron can jump from valence band to conduction band. Therefore, electron in the conduction band is free. Electron in the valence band is not free. And how do I make an electron free? If the electron can jump from valence band to conduction band, then it is free. Easy? Now, I will analyze valence band and I'll analyze conduction band for conductors, semiconductors, and insulators. Okay. Now listen, look at the screen. So here, for conductors, the valence band, this is valence band, and this is called the conduction band. For conductors, my valence band and conduction band, they overlap. So all electrons which are in the valence band can easily jump to conduction band, because for conductor, I want complete electricity. That means all the electrons should be able to jump from valence band to conduction band. Okay, all the electrons should be able to jump from valence band to conduction band. And what is the best way to make sure that electrons can jump from one band to the other? By making sure that there is no gap between the two bands, so electrons can easily travel. But if you look at semiconductors, there is a small gap between valence band and conduction band. So only few electrons can jump. And if only few electrons can jump, can I say electricity is only partially conducted, or there is only partial electricity? Over here, can I say all the electrons can travel from valence band to conduction band? Therefore, complete electricity is possible. In semiconductors, since there is a gap between valence band and conduction band, only few electrons can jump. Therefore, only partial electricity is possible. And for insulators, the gap between valence band and conduction band is so much or so high that no electrons can jump from valence band to conduction band. And if no electrons can jump from valence band to conduction band, can I say no electricity is conducted? Therefore, can I say for insulators, no electricity is conducted. For semiconductors, partial is conducted. And for conductor, full electricity is conducted. If I ask you why conductors conduct full electricity, you will tell me because there is no gap between valence band and conduction band. If I ask you why semiconductors conduct partially, because there is a small gap between valence band and conduction band. And for insulators, the gap is large between valence band and conduction band. Is this much clear? Now, how do I measure the gap? Since it is energy, how do I measure the gap? I will measure the gap. What is the SI unit of energy? SI unit of energy is Joule. But in this chapter, we will measure energy in electron volt. It is one more unit of energy. It is not the SI unit, but it is a practical unit in this chapter. Therefore, in this chapter, the energy will be measured in electron volt itself. In this chapter, energy will be measured in electron volt. Therefore, can I say, for conductor, energy gap or the gap between valence band and conduction band is 0 electron volt because they are overlapping. For semiconductor, the gap is small. Gap is small means gap is lesser than 3 electron volt. And for insulators, the gap is greater than 3 electron volts. If you see here, EG means energy gap. Energy gap is greater than 3 electron volt. Therefore, can I say in simple words, look at the screen. For conductors, energy gap is 0 electron volt. For semiconductor, energy gap is lesser than 3 electron volt. And for insulators, energy gap is greater than 3 electron volt. Now, what will happen over here? Since there is no energy gap, all electrons can travel. Since the energy gap is small, some electrons can travel. Since the energy gap is large, no electrons can travel. Therefore, can I say conductors, all electrons can travel? Semiconductors, few electrons can travel. And insulators, 0 electrons can travel. And if 0 electrons can travel, it will not conduct electricity. Okay, this is the basic. Now I'll give you the notes so that you can understand better. Write down classification of solids. Write down the side heading. Classification of solids based on based on band theory. Classification of solids based on band theory. Classification of solids based on band theory. Write down. Next, based on band theory, write down the notes. Based on band theory, solids are classified into based on band theory, solids are classified into based on band theory, solids are classified into first conductors, second semiconductors, third insulators. Based on band theory, solids are classified into based on band theory, solids are classified into first one conductors, second one semiconductors, and third one insulators. Based on band theory, solids are classified into conductors, semiconductors, and insulators. Now write down side heading conductors. Now write down side heading conductors. Write down side heading conductors, and below that draw this diagram. Below conductors, draw this diagram. Below the diagram, finish the diagram. Now below the diagram right now. Conductors are solids in which conductors are solids in which conductors are solids in which energy gap between valence band and conduction band. Conductors are solids in which energy gap between valence band and conduction band is 0 electron volt. Conductors are solids in which energy gap between valence band and conduction band is 0 electron volt. Example, metals. Example, metals. Conductors are solids in which the energy gap between valence band and conduction band is 0 electron volt. Example, metals. Next side heading write down semiconductors. Next side heading write down semiconductors and draw this diagram. Next side heading write down semiconductors and draw this diagram. Finish the diagram. Below that, write down. Semiconductors are solids in which, write down. Semiconductors are solids in which semiconductors are solids in which semiconductors are solids in which energy gap between semiconductors are solids in which energy gap between valence band and conduction band, energy gap between valence band and conduction band the energy gap between valence band and conduction band is lesser than 3 electron volt. Is lesser than 3 electron volt. Energy gap between valence band and conduction band is lesser than 3 electron volt. Example, silicon and germanium. Silicon is Si and germanium is Ge. Example, silicon and germanium. Silicon is Si and germanium is Ge. Written. Next side heading, insulators, and draw this diagram. Next side heading, insulators, and draw this diagram. Clear on it or not?
Vedant. Present, Miss. Vincent.
Now on the insulators, write down. Insulators are solids in which insulators are solids in which insulators are solids in which energy gap insulators are solids in which energy gap between insulators are solids in which energy gap between Insulators are solids in which energy gap between valence band and conduction band. Insulators are solids in which energy gap between valence band and conduction band. Insulators are solids in which energy gap between valence band and conduction band is greater than 3 electron volt. Insulators are solids in which energy gap between valence band and conduction band is greater than 3 electron volt. Example, glass, wood, plastic. Example, glass, wood, plastic. So to summarize here, in a conductor, energy gap is 0 electron volt. In a semiconductor, energy gap is lesser than 3 electron volt. And for an insulator, energy gap is greater than 3 electron volt. So just write down a summary table below the notes. That means for a solid, energy gap is 0 electron volt. That is for a conductor. For a semiconductor, it is lesser than 3 electron volt. And for an insulator, it is greater than 3 electron volt energy gap. For a conductor, it is 0 electron volt. Semiconductor is less than 3. And for insulator, it is greater than 3. Okay. This completes the first topic of band theory of solids. This completes the first topic of band theory of solids. Read it and tell me if you have any doubts. If you see the last page of your textbook, see here, I have displayed it on the screen. This is your book bag questions. If you see, we have completed this question. Just check. Answer in detail. Explain how solids are classified based on band theory of solids. For this question, this is the answer. This is our first topic. Just check whether you have understood. We have completed in your book bag, last page of your textbook. There are question answers. We have completed question number 3 in that question number 1. Just check. Okay. Now, so listen, look at the screen. We had solids. In solids, I had conductors, I had semiconductors, and I had insulators, correct? In solids, I had conductors, semiconductors, and insulators. Now, going ahead, I will not do anything about conductor, means I'll not study about conductor. I will not study about insulator. I will only study about semiconductor now, because the chapter's name is semiconductor. So I will not study about conductor. I will not study about insulator. I will study about semiconductor. Now listen to me. There are two types of semiconductors. One is called intrinsic semiconductor and one is called extrinsic semiconductor. I will repeat. What did we study first? We studied three types of solids: conductors, semiconductors, insulators. Now going ahead, we will not study anything about insulators and conductors because the chapter is semiconductors. We'll study more about semiconductors. Therefore, in semiconductors, I have two types of semiconductors. One is intrinsic and one is extrinsic. Now, what is intrinsic and what is extrinsic? Let me tell you. Now, pure semiconductor that is found in nature is called intrinsic semiconductor. And if I make any change to that semiconductor, it is called extrinsic. Means something that is pure is intrinsic. If I take that and make some change to it, it is called extrinsic. For example, listen to me. Can I say milk is intrinsic, milkshake is extrinsic? Means milk is naturally available in nature. But if I make some changes to milk and make it milkshake, it is called extrinsic. Tree is intrinsic because tree is found in nature. But furniture is extrinsic because making use of the wood, I make something else that is called extrinsic. Okay. Like that, I can say cotton plant and clothes. Cotton plant is intrinsic. Clothes are extrinsic. Did you understand? Animal skin is intrinsic, leather is extrinsic. So anything that is found naturally is pure, that is intrinsic. And what we do, changes on that, that is called extrinsic. So we'll go one by one. So if you see types of semiconductors, there are two types of semiconductors. Okay, there are two types of semiconductors. 1 minute. There are two types of semiconductors. If you see, first one is intrinsic semiconductor, second one is extrinsic semiconductor. Don't write, just listen. So what is an intrinsic semiconductor? Read on the screen what is written. Extremely pure semiconductor is called intrinsic semiconductor. Extremely pure semiconductor is called intrinsic semiconductor. Example is pure silicon and pure germanium. So if I ask you, give me example of semiconductor, you will tell me germanium and silicon. But if I ask you, give me example of intrinsic semiconductor, you will tell me pure germanium and pure silicon. Pure germanium and pure silicon. Therefore, write down side heading, types of semiconductors. Write down the side heading, types of semiconductors. Types of semiconductors and write down. First one, intrinsic semiconductor. Second one, extrinsic semiconductor. Types of semiconductors, intrinsic semiconductor and extrinsic semiconductor. Well done. First one is intrinsic and second one is extrinsic. First one is intrinsic and second one is extrinsic. First one is intrinsic, second one is extrinsic. Now write down the side heading again. Intrinsic semiconductor. Write down the side heading again. Intrinsic semiconductor. Write down the side heading again. Intrinsic semiconductor. See what is written on the screen. The same thing you need to write. Extremely pure semiconductor is called intrinsic semiconductor. Example is pure silicon and pure germanium. Right. Extremely pure semiconductor is called intrinsic semiconductor. Example, pure silicon and pure germanium. Extremely pure semiconductor is called intrinsic semiconductor. Example is pure silicon and pure germanium. Now, next side heading, extrinsic semiconductor. Next side heading, extrinsic semiconductor. Correct, Nitesh? Next side heading is extrinsic semiconductor. So listen, look at me. I take one intrinsic semiconductor, I add something to it, so it becomes extrinsic. Because pure is intrinsic, if I add something to it, that is called extrinsic. The thing that I add is called dopant. The thing that I add is called dopant. The process is called doping, and then the semiconductor becomes doped semiconductor or extrinsic semiconductor. I will repeat. Intrinsic semiconductor is a pure semiconductor. Now, if I add something to it, it is called extrinsic. Now, what I add is called dopant, D-O-P-A-N-T. What I add is called dopant. The process is called doping. And then the semiconductor becomes doped semiconductor. And the semiconductor becomes doped semiconductor or extrinsic semiconductor. Okay. Therefore, if you look at the definition of extrinsic semiconductor, look at the screen. Okay. The process of adding impurity to semiconductor is called doping, and the impurity atoms are called as dopants, and doped semiconductor are called as extrinsic semiconductor. Example, doped germanium and doped silicon. Okay, so make a note of this. Write down side heading extrinsic semiconductor and write down the process of adding impurity to pure semiconductor. Same thing what is written right now. Written? So if I ask you, what is the example of a semiconductor, you will tell me germanium and silicon. If I ask you what is an example of intrinsic semiconductor, you will tell me pure germanium and pure silicon. If I tell you what is an example of extrinsic semiconductor, you will tell me doped germanium and doped silicon. You tell me it is doped germanium and doped silicon. Understood this much? Therefore, if you notice the textbook, come back to your textbook. See the second question under the same heading that you have seen. Look at the screen. Look at this question. Distinguish between intrinsic semiconductor and extrinsic semiconductor. We have finished this question also. Check. Distinguish between intrinsic semiconductor and extrinsic semiconductor. Now look at the question above. Main question number two. What is the importance of energy gap in it is not semiconductor, it is in a solid. So what is the importance of energy gap in a solid? We have drawn the table. You have to draw the same table. Means if the energy gap is 0, the solid is a conductor. If energy gap is less than 3 electron volt, solid is a semiconductor. And if energy gap is greater than 3 electron volt, it is an insulator. Is it clear? Therefore, this also you should be able to answer. Now, what is the answer for this? The answer for this is the table that you have taken as the summary. So this question is also done. And this question is done. And this question is done. Check. So we have finished two topics today. One is the band theory of solids and the types of semiconductors. Okay. Got it?
Yes, sir.
Now see this. We had in solids, we had three types of solids. That is conductors, semiconductors, and insulators. Okay. Then what did we do? We studied only about semiconductor. We stopped studying about conductor and we stopped studying about insulator. We started studying about semiconductor. In semiconductor, we have two types of semiconductors. One is intrinsic semiconductor and one is extrinsic semiconductor. So now what we will do is, we will not study anything about intrinsic anymore because we cannot do anything, it is pure. We will study about extrinsic semiconductors or doped semiconductors. Please understand the flow. We will stop studying about conductors and insulators. We started studying only about semiconductors. In semiconductors, I had intrinsic and extrinsic. I stopped studying about intrinsic. We have only extrinsic. In extrinsic, I have two types of semiconductors, and those semiconductors are called as N-type semiconductor and P-type semiconductor. Don't write, just listen. We have N-type semiconductor and P-type semiconductor. N-type means negative type and P-type means positive type. N-type semiconductor and P-type semiconductor. So under extrinsic, I have two types of semiconductors. One is negative type semiconductor and one is positive type semiconductor. So let me show it to you here. So the side heading is types of doped semiconductor or types of extrinsic semiconductor. So there are two types of extrinsic semiconductor. One is N-type semiconductor, another one is P-type semiconductor. Therefore, write down side heading types of extrinsic semiconductor. Types of extrinsic semiconductor or types of doped semiconductor. semiconductor or types of extrinsic semiconductor. First one, N-type semiconductor. First one, N-type semiconductor. And second one is P-type semiconductor. N-type semiconductor means negative type semiconductor and P-type semiconductor means positive type semiconductor. First one is N-type semiconductor, that is negative type, and second one is P-type semiconductor, which is positive. Written. Now we'll study about N-type semiconductor and P-type semiconductor in detail. Okay, now listen to me. There is one concept about semiconductors which you need to know and which you need to understand. Listen to me. Can I say in conductor, we have electrons and protons, correct? In conductors, we have electrons and protons. What is electrons and protons? Negative and positive. But in semiconductors, we have something called, listen to this. In semiconductors, we have something called electrons and holes. Listen to me carefully. Look at the screen. In normal conductors, I have something called electrons and protons. But in semiconductors, I have something called electrons and holes. Means there is no concept of protons in semiconductors. In semiconductor, instead of protons, I have holes. It is not actually the same as protons, but you should understand that in semiconductors, I have electrons and holes. Electrons are negative, holes are positive. Electrons are negative, holes are positive. That means instead of proton, I have a word called holes. Holes is nothing but a vacancy, or you can consider it as positive. That means if you see the word proton in the question paper, that means the question is 100% not from semiconductors. And if you see the word holes in the question paper, that means the question is 100% from semiconductor, because no other chapter has the concept of holes. That means if you look at the semiconductor textbook, the entire textbook of that, in the entire chapter of semiconductor, there is no mention of proton. It is only holes. Therefore, in the exam, if you look at the question paper, if you get the word holes, it is semiconductor. And if you get the word protons, it is not semiconductor. Okay. Therefore, that is the first concept you should know. Therefore, semiconductor has electrons and holes instead of electrons and protons. The next thing you should understand is all semiconductors, means germanium and silicon, have 4 holes in the outermost orbital. That also you should know. So first thing you should know is every semiconductor has electrons and holes, not electrons and protons. And second thing you should know is every semiconductor, that is germanium and silicon, they have 4 holes in the outermost orbital. Now, based on this logic, we will study what is N-type semiconductor and we will study what is P-type semiconductor. Therefore, write down the side
Can you
heading.
please repeat
N-type. Which point?
the last one?
The last one is
protons.
germanium and
Protons
silicon have
holes.
4 holes in the outermost orbital.
Okay, sir.
Germanium and silicon have 4 holes in the outermost orbital. Now let us study N-type semiconductor. Okay, let us study N-type semiconductor. Don't write. First, let me explain and then you write. Look at the screen. I have something called N-type semiconductor. Please listen to this. N-type means what? Negative type. Negative type means electron is conducting. P-type means what? Positive type. That means hole is conducting. But now we are learning N-type semiconductor. So listen, first let me take germanium or silicon. Now if I take germanium or silicon, they will have 4 holes in the outermost orbit. Correct? They will have 4 holes in the outermost orbit. Now to this, I will add pentavalent impurity. I will add what? Pentavalent impurity. Now, what is the meaning of the word pentavalent? Penta means 5. Therefore, pentavalent impurity is an impurity that has 5 electrons. Now, when I add a pentavalent impurity, what happens is this electron and this hole will combine because negative and positive will attract. This electron and this hole will combine. This electron and this hole will combine. This electron and this hole will combine, leaving behind one free electron to conduct. Now, since electron is conducting, it is called as negative type semiconductor. If hole was conducting, it would be called positive type semiconductor. But since electron is conducting, it is called as negative type semiconductor. Okay. And in this type of semiconductor, number of electrons is greater than number of holes. Because for every atom, there are 5 electrons and 4 holes. Like that, if you go on and if you continue, you will have number of electrons will be far greater than number of holes in N-type semiconductor. Therefore, the diagram that I have drawn even in the module, look at this, the diagram that we have drawn in the module. Check. I'll explain again. I have pure germanium and pure silicon. They have 4 holes in the outermost orbit. Then I add pentavalent impurity. Pentavalent impurity means 5 electrons I will add. Out of that, 1, 2, 3, 4 electrons will combine with 4 holes, leaving behind one free electron, which is free to conduct. Now, since electron is conducting, it is called as N-type semiconductor. And in this type of semiconductor, number of electrons are greater than number of holes. Okay. Then I will give you the definition. So what I want you guys to do is, I want you guys to write the side heading N-type semiconductor and draw this diagram. Start. Write on the side heading N-type semiconductor and draw this diagram. Okay. Draw the diagram. Only the diagram, nothing else. Finished the diagram. Now below the diagram, see what is written. Just see. this is the definition, okay, of N-type. Listen, definition. When silicon or germanium is doped with pentavalent impurity, such as phosphorus, arsenic, antimony. You can remember that with the code word up, AAP. How can remember with the code word up? It is arsenic, antimony, phosphorus. Very important to know the impurities. We get N-type semiconductor. Therefore, if they ask in the exam, tell some pentavalent impurity, then you know that pentavalent impurity is all this: arsenic, antimony, and phosphorus. Don't write, listen first. If they ask you what is the definition of N-type semiconductor, we have to write exactly what is this much. That is, when silicon or germanium is doped with pentavalent impurities such as arsenic, antimony, and phosphorus, we get N-type semiconductor. This is the definition. Working, I will dictate, but write down the definition of N-type semiconductor. Working, I will dictate. Okay, finish writing the definition. Now, below that, write down the side heading, working. 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 Now, I'll dictate the working. Write down silicon/germanium, silicon/germanium, silicon/germanium have 4 holes in the outermost orbit. Silicon/germanium have 4 holes in the outermost orbit. Switch on your cams. I've been told to put you out if you don't switch on your cams. So randomly I'll start putting people out. Okay. This is the last time I'm doing it. Silicon/germanium have 4 holes in the outermost orbit. Full stop. Right now. When pentavalent impurity is added, when pentavalent impurity is added, when pentavalent impurity is added, four electrons, when pentavalent impurity is added, 4 electrons combined with 4 holes. When pentavalent impurity is added, 4 electrons combined with 4 holes, leaving behind leaving behind one free electron to conduct. 4 electrons combine with 4 holes, leaving behind one free electron to conduct. Leaving behind one free electron to conduct. Full stop. Since electron is responsible for conduction, since electron is responsible for conduction, since electron is responsible for conduction, this type of semiconductor is called, since electron is responsible for conduction, this kind of semiconductor is called, this kind of semiconductor is called N-type semiconductor. This kind of semiconductor is called N-type semiconductor. Now I'll repeat. Germanium/silicon have 4 holes in the outermost orbit. When pentavalent impurity is added, 4 electrons combine with 4 holes, leaving behind one free electron to conduct. Since electron is responsible for conduction, it is called N-type semiconductor. Full stop. In this type of semiconductor, number of electrons is greater than number of holes. In this type of semiconductor, number of electrons is greater than number of holes. In this type of semiconductor, number of electrons is greater than number of holes. That's it. This is your N-type semiconductor. Did you understand? Okay. Now, next side heading write down P-type semiconductors. Next side heading write down P-type semiconductors. Pratiksha, what do you want me to repeat them?
The last sentence.
In N-type semiconductors, number of electrons is greater than number of holes. Okay. Now look at this. Now when I go for P-type semiconductor, the starting is the same. I will take germanium or silicon crystal, and germanium or silicon crystal will have 4 holes in the outermost orbit. To this, I will add trivalent impurity. Trivalent impurity is an impurity that has 3 electrons, because what is the meaning of tri? 3. Therefore, 1 electron, 1 hole, 1 electron, 1 hole, 1 electron, 1 hole will combine, leaving behind one free hole to conduct. Now, since hole is responsible for conduction, it is called as P-type. In the previous one, electron was responsible for conduction, so it was called negative type. In this case, hole is responsible for conduction, so it is called as positive type. And therefore, can I say for this type of semiconductor, number of holes is greater than number of electrons. Number of holes is greater than number of electrons. Therefore, look at the thing that I have written in the module. See here, P-type semiconductor. Look at the diagram. I have taken pure germanium and pure silicon crystal, which have 4 holes in the outermost orbit. Then I add trivalent impurity, which has 3 electrons. Now these electrons combine with holes, leaving behind one free hole to conduct. And in this type of semiconductor, number of holes are greater than number of electrons. This is the diagram for P-type semiconductor. Therefore, first draw the diagram of P-type semiconductor, then we'll do the definition. Start drawing the diagram for P-type semiconductor. Okay, now see below the diagram the definition of P-type semiconductor. See below the diagram the definition. When silicon or germanium crystal is doped with trivalent impurity, such as now it is boron, aluminium, indium. We can remember it as Bi. Boron, aluminium, and indium, we get P-type semiconductor. This is the definition. Start writing the definition of P-type semiconductor. Start writing the definition of P-type semiconductor. Okay. Below the definition, I'll have to give you the working. Okay. So finish writing the definition first. Okay. Below that, write down side heading working. Below that, write down side heading working. And write down germanium / silicon. Write down germanium slash silicon, germanium slash silicon, germanium slash silicon have 4 holes in the outermost orbit. Germanium slash silicon have 4 holes in the outermost orbit. Full stop. When trivalent impurities are added, when trivalent impurities are added, when trivalent impurities are added, 3 electrons, when trivalent impurities are added, 3 electrons combine with 3 holes. When trivalent impurities are added, 3 electrons combine with 3 holes, leaving behind one free hole to conduct. Leaving behind one free hole to conduct. Leaving behind one free hole to conduct. Full stop. Since holes are responsible for conduction, since holes are responsible for conduction, since holes are responsible for conduction, this type of semiconductor is called, since holes are responsible for conduction, this type of semiconductor is called, this type of semiconductor is called P-type semiconductor. This type of semiconductor is called P-type semiconductor. This type of semiconductor is called P-type semiconductor. Correct, Veer? They've all been students here. This type of semiconductor is called P-type semiconductor. Next, in this type of semiconductor, 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 number of holes in this type of semiconductor, number of holes is greater than, in this type of semiconductor, number of holes is greater than number of electrons. Okay, Veer?
Yes, sir.
I want the camera on.
This is the OBS virtual camera, sir. My laptop does not have a proper camera.
This will not work, right? We need camera on. This is for all of you.
I can click a picture and like send it that it does not give any other option.
No, that is a temporary solution. We don't want that. Anyway, after the break, we will anyway So for people who are not. Okay. Now we have done N-type and P-type. Now, if they ask you which is better, which kind of semiconductor is better, N-type semiconductor or P-type semiconductor? In N-type, electron is conducting. In P-type, hole is conducting. Okay. Now, if in N-type electron is conducting and P-type hole is conducting, which kind of semiconductor is better? The answer is N-type semiconductor. I'll tell you why. Because electrons are faster than holes, or electrons have more mobility than holes. What is the meaning of mobility? Ability to move. Mobility is ability to move. Therefore, if you are asked in any form, which kind of semiconductor is better, then the answer is N-type of semiconductor is better, because electrons have more mobility. Because electrons have more mobility. Okay. With that, okay, we will start with. I will show you some questions from the book back. So just go to your book back. Go to your book back. See the first MCQ and tell me what do you think should be the answer for this MCQ. First one. Check and tell me. Electric conduction through semiconductors is due to.
D.
Electric conduction in semiconductor is due to. Answer? Answer is because of both electrons and holes. Because electrons are responsible for N-type semiconductor and holes are responsible for P-type semiconductor. Therefore, can I say conduction can be because of both electrons and holes? Therefore, answer for the first one is D. Check. Got it? Now, come to your second question. Answer the following questions. In that, see the second question and tell me what do you think is the answer for this. Which element would you use as an impurity to make germanium N-type semiconductor? Tell me, what is the answer for this?
Pentavalent.
Aromatic, antimony, or phosphorus.
Arsenic, antimony, and phosphorus, pentavalent impurities. Therefore, I want you to write this question as question number 2 in that 2 and write down this answer. Arsenic, antimony, and phosphorus. Write down. Write the question and write the answer as well. Now look at question number 5. Now look at question number 5. Okay. Now if you look at question number 5, why is the conductivity of N-type semiconductor greater than that of P-type semiconductor when both of them have the same level of doping? When both of them have the same level of doping. Answer is same, because mobility of electrons is more. Correct? We have just done it because mobility or speed of electron is more. Correct, Ronaldo?
Yes, sir.
What is your image, Ronaldo?
ऐसे वीडियो ऑन रखता तो फिर जो आप बोलते हो वो सुनाई नहीं देता ठीक से सर, नेट इशू होता है।
All this will not work after the break. Okay.
Okay, sir.
Write down the question and write down the answer. Why is the conductivity of N-type semiconductor greater than the P-type semiconductor even when both have the same level of doping? Answer is because mobility of electrons is more. Because mobility of electrons is more. Because mobility of electrons is
Can you again repeat the answer of this question?
because mobility of electrons is more, or electrons have greater mobility. Both are correct. Mobility of electrons is more, or electrons have greater mobility. Right. Finish writing this much. So go through it. Whatever I have underlined, all those MCQs and all those answers we have done. So tell me if you have any doubts. So we have done what is band theory of solids. We have done what are types of semiconductors, that is intrinsic, extrinsic. Then we have done two types of extrinsic semiconductors, that is N-type and P-type. So tell me clear, everything is clear. Any doubt in any topic, let me know, and then we will continue. I'll wait for 1 minute. Let me know if you guys have any doubt in any of the topics or any of the questions that we have highlighted on the screen. That is a look back. Okay, so what we will do right now is we will take a break, and after you come back, we will start with the next part of the chapter. Thakur batch and Andheri evening batch first. Tell me which chapter is remaining after semiconductors. We are done, right? Evening after semiconductors.
Yes,
Or
miss.
we have
Yeah, sorry,
we
yes,
are
sir.
done. And Thakur, which chapter is remaining after semiconductors?
Sir, I guess we started with electrostatics and it is incomplete.
Electrostatics is over in Thakur.
Okay.
Any other chapter remaining in Thakur other than electrostatics? Okay, fine. So we'll take a break. We come back with the same link at 9 o'clock. Exactly at 9, we will continue. So join back with the same link at 9 o'clock. Okay, thank you.